Hello everyone, today we are going to do an exercise named related rates intro. So let's start. A radius of a square is increasing at a rate of 0.5 centimeters per minute. At a certain instant, the radius is 17 centimeters. First, what is the volume of this? What is the volume of the sphere? The sphere's volume is so now let's say it is equal to V equals to 4 by 3 pi r cubed. This is its volume, and we know that the radius of sphere is increasing at a rate of 0.5 centimeters per minute. So we also know that dr with respect to time is equal to 0.5 centimeters per minute. So we know this, and at a certain instant the radius is 17 centimeters. Radius equals to 17 centimeters. What is the rate of change of the volume of the sphere at that instant in cubic meters per minute? The volume of the sphere with the radius r is this. So we already knew that. So we want to find what is dv over dt. So in this, let's take the derivative of both sides with respect to time. So this will become, let's do it over here, this will become dv over dt is equal to, and we can take out 4 over 3 and pi because they are constants, and inside there will be, not like this, and here it will be a derivative d over dt of r cubed. So let's write it again, r cubed and close brackets. So this is our dv over dt. So let's try it in these values. These are constants, so we do not need this. So let's first take the derivative of r with respect to r. So this becomes dv over dt, let's write it over here only, is equal to 4 over 3 pi times 3r squared, the derivative of r with respect to r, times dr over dt. So this is it, and we want to find this. Dr dt is, we know, is 0.5 centimeters per minute, and radius equals to 17. We also know this. So this will become, this whole thing is equal to 4 by 3 pi times 3 times 17 times 17 times 1/2 centimeters per minute, and radius is, this will be in centimeter squared, so whole thing will be centimeter cube. So let's write cube here. So this whole thing will be in these units, in cubic centimeters per minute. Let's solve this now. Let's use a calculator because it's hard to calculate this on our own. So this will cut with this will cut with this will become 2. So 2 times 17 times 17, yes, this is it, 2 times 17 times pi. This is equal to this, and times pi, 578 pi centimeter cube per minute at that instant. So correct. The radius of a sphere is decreasing at a rate of 1 meter per hour. At a certain instant, the radius is 4 meters. So we know that the radius dr over dt is equal to negative 1 meter per hour, and at a certain instant the radius r is equal to 4 meters. What is the rate of change of the volume of the sphere? As we know it, the volume is equal to the volume, let's say V is equal to volume is equal to 4/3 pi r cube. This is the volume of the sphere at that instant at 4 meters in cubic meters per hour. So let's solve this. Let's take the derivative with respect to time on both sides. This will become dv over dt is equal to d over dt of 4/3 pi r cubed, and we can take the constants out of this, so this will become, let's write it over here, dv over dt is equal to 4 pi thirds is times d over dt of r cube. So this becomes dv over dt is equal to 4 pi over third. I can write it better. This becomes 4 pi over third times the derivative of r with respect to r. This becomes 3r squared times the derivative of r with respect to t. This becomes dr over dt. Close the brackets. So this is our derivative. Let's solve this by filling in this value, and we also know dr dt. So we know that dv over dt is equal to 4 pi thirds times 3 times 16, because 4 times 4 is 16, and times dr dt we know is -1, and this whole thing will be in, this is meter, so meter squared, and meter squared times meter is meters cubed per hour, so meters cubed per hour. This is in these units in cubic meters per hour. So let's solve this. 3 cancels with this. 4 times 16 times -1. This will be negative. So put out the calculator. 16 times 4 is equal to 64. 64 times -1 is -64. -64 pi meters cubed per hour. At that, the radius equals to 4 meters. Correct? The radius of a base of a cone is increasing at a rate of 10 meters per second. So we know that the radius of the base of a cone, the volume of cone with radius r and height h is this. So first let's see this. Let's say V equals to the volume of the cone. This is equal to pi r square h over 3. Pi r squared height thirds h over 3. So this is the area, this is the volume of the cone, and we know that the radius is equal to the dr dt with respect to time is equal to 10 meters per second. So we know this. Then the height we know is 6 meters. H is equal to 6 meters, and we also know that at a certain instant the radius is equal to 1 meter. So we know these 4 things. What is the rate of change of volume of a cone at that radius equals to 1 in cubic meters per second? So let's take the derivative with respect to time of both sides of this equation. So this becomes dv over dt times Let's take out the simple values. We know that h is 6, so this one 6, this becomes 2, so it's become 2 pi r squared. 2 pi r squared, so is this thing is equal to 2 pi times the derivative with respect to time of r squared, as you know it. So this becomes, we do it here, dv over dt is equal to 2 pi times the derivative of r squared with respect to r is equal to 2r times, let me put these in brackets, times the derivative of r with respect to time, which is dr over dt. So this is our derivative, and let's fill in the values. What we know, dr dt we know is 10. We know this is 10. dr over dt, and we know this is 10 meters per second, and r we know is 1, so this whole thing becomes 2, and this becomes, let's solve this dv over dt is equal to 2 pi times 2 times 10, 2 meters times meters is equal to, this was pi r squared, this becomes 2r, so this becomes 2 times this, so cubic meters. Did I do that right? Yes, because height was in meters also. So this becomes cubic meters cubed divided by second per second. So let's solve this. This becomes 20, and 20 times 2 becomes 40, so this whole thing becomes 40 pi meters cubed per second. 40 pi. Let's check. Correct. A radius of a base of cylinder is decreasing at a rate of 12 kilometers per second. The height of the cylinder is fixed at 2.5 kilometers. At a certain instant, the radius is 40 kilometers. So we know a lot of things. We know that the radius is equal to 40 kilometers. And we also know that the height is equal to 2.5 kilometers. And we also know that the radius average rate of change dr with respect to time is equal to 12 kilometers per second. So we know these. And what is the rate of change? So first of the volume, so this is the volume, pi r squared h. So let me write over here, v is equal to pi r, this is equal to pi r squared h. Yes, so we know h is equal to 2.5 kilometers. This is 2.5, so we can do it like this, dv over dt, the derivative with respect to time is equal to, let's pick out the 2.5 and pi's because these are constant values, and this is times the derivative with respect to time of r squared. This is d. So with respect to r, so this becomes, first we use the chain rule in this, so this whole thing becomes dv over dt is equal to 2.5 pi times 2r, the derivative of r with respect to r, and times this will become dr over dt. Let's put them in brackets. So this becomes dv over dt. So let's solve this. This becomes Let's put in the values. We know dr dt is equal to 12, and we also know r is equal to 40 kilometers. So this is 40. So let's solve this. This becomes dv over dt is equal to 2.55 times 40 times 12, and this whole thing is in kilometer times kilometers is kilometer squared. Kilometer squared times the dr dt is cubic kilometers per second. So let's solve this. This 2.5 is equal to 5 halves. 5 times 40 times 12. Let's cancel out with this. Let's cancel out with this. This becomes 6. 40 times 6 is 240. 240 times 5. 240 times 5. 240 times 5 is equal to 1200. This will negative, so negative 1200. Negative 1200, and let's see what we did problem. 240 times 5 was minus 1200. Switch minus. Let's check this answer. Correct.